This is Euclid Book 10, proposition number 82. And what I decided to do this time is, we already know how we get all these squares. I have told you this over and over in every single proof that we have done up to this point. So you know how we got the squares. You also know how we got the rectangles. We have rectangle ADDB and ACCB. So what I have done here is I'm representing the squares and the rectangles with numbers. This is square number 1, square number 2, square number 3, square number 4, square number 5, and square number 6. And this is going to be very important for this particular proof. It will also help you understand some of the other previous proofs that we have done along the way. Let's get into this. To a minor straight line only, one straight line can be annexed, which is incommensurable in square with the whole, and which makes with the whole the sum of the squares on them rational, but twice the rectangle contained by them medial. Let AB be the minor. Okay, this is a minor line. And let BC be annexed to AB. So we're going to annex this to that. Therefore, ACCB, this length right here and this length right here, they are straight lines. They are incommensurable in square, which makes the sum of the squares on them rational. So if you were to add, okay, if you were to add this square and this square together, that sum would be rational, but twice the rectangle contained by the medial. Okay, so this rectangle is medial. Actually, what happens here in this case is that twice the area of this is medial. The sum of these two is rational. The twice of this is medial. Okay, this is by Euclid Book 10, proposition number 76. I say that no other straight line can be annexed to AB, fulfilling the same conditions. For if possible, let BD be so annexed. We're going to annex this to that. Therefore, ADDB, this whole line to this, are also straight lines incommensurable in square. Okay. So in other words, this line here and this line here are incommensurable in square, and they fulfill the aforesaid conditions, which is by Euclid Book 10, proposition number 76. Now, since the excess of the squares on ADDB, now, what you have to do on this is you have to add the area of this square and this square together, and that is going to be this total right here. Okay? Then you're going to add this square and this square together, and that's going to be this total right here. And when you subtract this total from that total, you'll get R. Now here's the kick. If you multiply the area of this rectangle by 2, that's what you'll get here. If you multiply the area of this rectangle right here by 2, you'll get this here. And if you subtract this area from this area, you will also get R. It's the same number. This R is the same number as this. Does that make it clear enough for you? Okay. While the squares on ADDB, well, that would be this area and this area combined, exceed the squares on ACCB, as I said, we're going to add these two areas together, we're going to add these two areas together, and whatever answer we get is going to be a rational area. And the reason we can say this is because these two areas are rational. Therefore, twice of this area exceeds twice of this area by a rational area, which is impossible because both are medial. Okay? This is by Euclid Book 10, proposition number 26. Therefore, to a minor straight line, only one straight line can be annexed, which is incommensurable in square with the whole, and which makes the squares on them added together rational, but twice the rectangle contained by the median. And that is the whole proof. Alright. I will tell you more in a future video, so I want you to stay tuned.